And I talked about that earlier, meaning that's basically just saying you're looking in the first quadrant. X greater than 0 means we're on the right half, y greater than 0, we're on the top half. So now I've got this part. As far as graphing this goes, I don't like the way this looks, so I'm going to change it. I'm going to change that so that it's y is greater than or equal to a negative x plus 3. So we go 3, and it's negative x, so down 1 over 1. And it's y bigger, so we're shading up. So right now we were just in the first quadrant. Now we've drawn this line, so now we're shading up this way. And the last one, again, I don't like the way that looks. So I'm going to put y is greater than or equal to a negative 2x plus 4. So I go 4, and then it's down 2 over 1. And I draw my line. And this is also greater, so I shade up. And now here's the important part. The important part is what's the overlap. So the overlap, well, we started with our first quadrant, then we did this part, and then we did this part. So my answer is this area. Now, you need to use graph paper with this stuff. And the reason you need to use graph paper, so part 1 is coming up with a picture. But the next thing that we have to do is we need the corner points of this region. So I need to know, like this corner is 0, 4. So I need to be able to identify exactly where this coordinate is. That one's not so bad. I need to identify exactly where this coordinate is. That one's not so bad. I need to identify where this coordinate is, right? If you're not using graph paper, that may be hard to identify. So it's pretty easy to identify that this is the coordinate 0, 4. It's pretty easy to identify this is the coordinate 0, 3, 3, 0. It's hard to identify, and it might be easy to identify that this is 1, 2, but as sometimes those intersection points aren't as nice, it's going to be much harder to identify points without graph paper. So what I want you to do at the beginning of every day, I'm going to, I'll start putting files in the file tab in Teams of example problems that I'm going to use. If you've got a printer, you can print those out so that you'll have graph paper. Or if you're writing on your device, obviously you just put graph paper on that. But that's our first one. Now all of this is, we're doing skills so that we can do these complicated problems that are actually going to start tomorrow. And the skill set is, given this, can you come up with this picture? Most of the time when you graph your system, you end up with a nice little bounded, like little region. This is the case where it's unbounded. Let me see if people are asking questions. Okay. All right. So next up, I want you to graph this system. So we're going to start with x greater than or equal to 0, y greater than or equal to 0, x plus y is less than or equal to 5, x greater than or equal to 3, and y less than or equal to 1. I want everyone to graph that system. And after you graph this system, like put everything all on one grid, find the like once you shade your region, then do the little hand raise so I can know when to start. Yes. I'm glad it's Friday, but I don't get to sleep late tomorrow because I have a 3-year-old, and 3-year-olds don't know what it means to sleep late on Saturday. They get up. He gets up at 7 o'clock every day. Sometimes he sleeps to 7:02, but usually he's up by 7 every day. Folks, please keep your camera on. If you keep your camera on, most likely you're going to stay engaged. Plus, it makes it a whole lot easier for me to teach. If I get to see expressions, then I have an idea if I'm teaching, if I'm making it understandable. Oh, whoops, I needed to pause. All right. So we're dealing with our first quadrant. Now, if I talk about x is greater than 3, anytime you see x equals, that's a vertical line. So if I'm at 3, 1, 2, 3, that's a vertical line at 3. And this thing says I'm shading to the right, so I'm going this way. When I talk about y less than 1, y equals is a horizontal line. So it's going to be a horizontal line at 1. Oops. Try to do a better job. And this is y is less than, so that means I'm shading down. So if I'm looking, right now, here's what I've got. I'm in the first quadrant. This line says, well, no, instead of starting here, I'm going to start here. Y is going up, right? Because y is greater than 0, so we're going up here, and this is going down. So right now, we're dealing with this little strip. We've got one more graph to deal with. I don't like the way that looks, so I'm going to put the x on the other side, so I get y is equal to negative x plus 5. So that means I start at 5, and I go down 1 over 1. And this thing says it's y smaller, so we're shading down. And all right, questions? Are we okay? Okay. And if we're looking at all this, it's like, okay, we're here, we were here, then we're here down, here up, and then down. Turns out the region we're interested in is this thing. And this is a prime example of why I don't want you super active with shading. Because if you get crazy with shading, it might be very hard, it would be very easy to miss that this is the area you're looking for. And so now that we have this little area, now you don't know why it's important, we're going to get there, but right now, once we get our region, what I want to do now is list our coordinates, like list our vertices. So if I start listing my vertices, like what's this coordinate? This is the coordinate 3, 0. What's this coordinate? It's 3, 1. What's this coordinate? It's going to be 4, 1. And if I list this coordinate, I get 5, 0. And at this point, you're just going to have to take my word for it, but these points become important to answering the big question. And right now, there's actually 3 major parts to doing these word problems that I'm going to talk about tomorrow. One major, given this, one big part is given this, how do you come up with this picture? And then another part is once you have those, you've got to come up with the coordinates and do something with them. But before I start throwing all the words at you, I want to make sure you can handle you can go from here to here. And so let's try it one more time. Let's say I give you y is greater than or equal to 2. And did I talk about how to read this yesterday?
You actually did not talk about that, but some people previously know.
Okay. So I want to make sure everybody understands how to read this. And the way you read this is not 1 is less than x and less than 5. Normally how I teach this is I ask for some volunteer to read it, and usually the first, just to tell me what this says, and someone will say 1 less than x 5, and I'll cut them off. I'll be really obnoxious about it. And then somebody else will say, well, they'll try to read almost the same, say the same way. And after a while of being obnoxious, either somebody says the right answer or I go ahead and tell you. And once I tell you, it's hard not to see it. The way you read this is you say x is in between 1 and 5. And if you look at that, you go, well, yeah, that is kind of right, isn't it? Like, where is x located? X is located in between 1 and 5. So you are going to graph this. I want to graph this, sort of graph this inequality, and then I want you to graph everything else and find your coordinates. But how you graph this inequality think of x equals, anytime you see x equals with graphs, those are going to be vertical lines. So this has got a vertical line at x equals 1. This has got a vertical line at x equals 5. And what this is telling us is that we're shading in between 1 and 5. So if I were looking at, this means I'm going to shade in between those two. All right, now your turn. So that we need, they're going to have this other equation at the bottom. I'm going to call it C. And so C is equal to 3x minus 2y. Now, what's the point of C? Well, in the word problem that we're going to do tomorrow, they're going to talk about maximizing and minimizing C. And what that means is I want C as big or as small as possible. How do you know how to make C as big or as large or as small as possible? Well, you notice C has an x and a y in it. And what we've got to do is use these coordinates, like there's an x part, there's a y part, use these coordinates to find out what C can be. So the way that works is I'm going to make up a little chart. I want to know what C is. So if x is 1 and y is 2, when I plug that into what C is, if x is 1, 3 times 1 minus 2 times 2, or 3 minus 4, then my value of C is going to be negative 1. If I plug in a 1 for x and a 4 for y in my C, it's going to give me 3 minus 8, which gives me a negative 5. If I plug in a 5 for x and a 2 for y, let's see, it gives me 15 minus 4, which is going to give me 11. And if I plug in a 5 for x and an 8 for y, let's see, 15 minus 16 gives me a negative 1. So if you've got, here's your coordinates, okay? If we plug our coordinates into our C, we get these different values. And the question that's actually going to happen at the end of the day is, what's the biggest value of C? Well, if I go through, the biggest value of C is 11. Or I might ask, what's the smallest value of C? If I scroll down, the smallest value of C is going to be that negative 5. And so like the questions will be, what's the biggest value of C? And so at that point, you'd say 11. If I say what the smallest value, you'd say negative 5. The other thing they'll ask is If the biggest value is 11, what caused that? Well, this coordinate caused it. And this is the skill that, so if we look at this, now granted there are no words yet. Here's our problem. We started off with a bunch of inequalities. We graphed our inequality. That gave us a region. That region gives us some coordinates. We have to use those coordinates in this other equation. And after we do that, then we can start answering the question. This is a pretty involved process. And this is before we actually start doing the word problem. Because tomorrow, what I'm going to give you is pretty much a paragraph. It's like 5 or 6 lines. And that 5 or 6 lines is going to start off, and from that 5 or 6 lines, you're going to have to figure out these things. And once you get these things, then you're going to do all of this. And what I want to make sure is that you're very comfortable going from here to here to here before I start throwing the word problems at you. So, let's look at your homework. As far as your homework goes, what I gave you was, first, I didn't like your textbook. Your textbook, the concepts are fine. The numbers are absolutely hideous. I think they go out of their way to make the numbers ugly. So when I can, I will avoid assigning problems out of your book because they're just not nice. And particularly when you're trying to understand a concept. So, I mean, when you're trying to understand a concept, making the numbers ugly doesn't help you as far as understanding a concept. So, I got these problems out of a different book. Your homework, it's in OneNote. Like last night's homework, I put the little title in OneNote where you go to the book. I copied this. I copied the problem out of the book, and at the top, I said your homework is 43 through 55 odd. And I want to make sure you understand what to do. There's a couple of problems at the end that I find interesting. But if you look at it, like 43 looks exactly like what I made you do. Graph that system, right? The one thing I am going to add, because we're going to use this on Monday, is when you graph the system, also write down the coordinates of the boundary, because we're going to use those. So the odd ones, if you look, notice none of these numbers are super ugly as compared to what your textbook offers. Your textbook offers just absolutely hideous numbers. What I would like to, where's my cursor? It's there, right? I want to look at the last two. So I gave you to 55, and what I want is they give you a picture and they say, write a system of inequalities. So you have to do 53. I'm going to do 54 to show you, okay? All right. So I'm going to show you how I set it up. I'm going to do 54. So if you look at 54, notice they've got a nice shaded region, and I want to talk about how do you come up with a system of inequalities that describe this shaded region. So, first, notice that we're in the first quadrant. This whole thing is shaded, it's all in the first quadrant, so I know since I'm in the first quadrant, I can go ahead and say it's going to be x is greater than or equal to 0 and y is greater than or equal to 0. Pretty much all of these problems, you get to say that. The second thing I notice is I have this horizontal line. And anytime you have a horizontal line, that's y equals. So since this is y equals, right, and the y value is 5, and this is shading down, so I'll say it's y is less than or equal to 5. Next thing I notice is I have a vertical line. Anytime you see a vertical line, that's an x equals something. So this is going to be x, and the x value they're interested in this case is 6. And we're shading to the left, so this is x is less than or equal to 6. So I've got, pretty much I just got the x greater than 0, y greater than 0. Now I've handled the horizontal line, I've handled the vertical line. The last thing I have to handle is this, like sort of the slanted line. And that's just a regular line. I use slope-intercept form. So this is going to be y. I see that it's shaded up, and since it's shaded up, I'm going to say greater than or equal to. I've got something x plus, I see that's got a y-intercept of 2, so I know I get to put a 2 here. And the last thing I've got to determine is the slope. Well, how do you find slope? Well, slope is basically directions from this point to this point, and this is going down 2 over 2. I guess technically you could do the y2 minus y1 over x2 minus x1, but honestly all slope is, it's a direction, so I want to go how far down and how far over. So if I go down 2 over 2, that reduces to 1, or negative 1. So that is my system of inequalities that describe this picture. Now,